Okay. So in the next section, we're just going to recap what we know because you're going to have to use it. So this should be pretty familiar with. Factoring. So we have our styles. So this one is a simple trinomial. So XX. Can you give me what multiplies to 24 and adds to 2? 4 and 6 would work. I need a plus 2 out of those numbers. Okay, complex. So my flow number is 12. Can you think of multiples of 12 that would get you a 13? One and 12 will do the pair. So 1x, 3x is that. That's only one option. 1, 4, or 2, 2 is that option. So what am I all going to need here to make a 12 and a 1? You see your partners? Okay, so my brackets are 1x, 3x in the front. My partnerships are 1x with the 1, 3x with the 4. And everything on that was plus. Okay, difference of squares. So we will go 2 brackets on a difference of squares. X squared becomes the xx, multiplies to 64, 8 times 8 with a plus and a minus. Okay, GCF, so I'm taking out something that's common. So this and this at most are divisible by 2m. Now, a bracket, what's left? 2m gets divided, so m. Divide by 2m plus 4. Okay, so these were the 4 that we've done. Now we're going to learn this new one called negative out, and it's just a GCF. Okay, so do you recognize I'm doing a negative out because I do not like working with negative x. So negative 1 bracket, I'm GCFing it out. I don't like my negative variable. So once I take the negative out, the x becomes positive. And if I take the negative out, the number is now positive 6. Okay, I always like writing the same kind of format. Okay, I like my x first and the number next, and I never like a negative x. Okay, so I don't like the negative x, so negative 1 bracket. Now I can write a positive x and a what with the number? Negative 9. Okay. In rationals, we know this big statement. You cannot divide by 0. So I'm always looking at the bottom. When I'm talking about restrictions, I have to just look at the bottom. So what is the value I don't want x to be? Because it would create the bottom to be 0. X is not allowed to equal 3. Because if it was, the bottom would say 3 subtract 3, which is 0. Okay, on this one, I'm only looking at the bottom. What don't I want x to be? 0. Okay, this bottom is like how we were doing our complex trinomials. So what's the answer? It's going to be a fraction answer. Remember how to do it as a complex? It's going to be opposite divide 1/2. Okay, the same thing we were doing when we were factoring and solving. Okay, so what don't I want x to be? It's the same idea. Think of your complex factors. -4/5. Okay, to get this answer, I'm going to do something that I know how to do first. So I'm going to factor it. And I think it's a simple trinomial. So multiplies to 40, 8 times 5. Get your numbers, -8 and a +5 to get to 40 and -3. So now I'm not allowed to have x equal 8. I'm not allowed to have x equal -5. Okay, so this is the same as we were doing when we were solving. We wanted to be 0. Now we just don't want to be 0. Okay, so this you can do it in 2 different ways. You can do opposite divide, or you can GCF an 8 out. Okay, you could have done opposite 16 divided by 8. That would have given you the 2 as well. Okay, we're going to do 3 more examples and then we're done. So reducing rationals, so we're going to factor everything we possibly can. So the top, can you do a simple trinomial factor for me there? Simple trinomial multiplies, adds. Did you pick 2 times 3? Multiplies to +6, adds to +5. On the bottom, can you factor? And it's a difference of squares. Okay, now here's the thing what reducing is. Do you see any multipliers on the top and bottom that are the same? I see an x plus 3 and an x plus 3. So they can cancel. And then that's my final answer. Okay, next. We're going to factor the top, and it's a complex. Do you see any partners that will get you a 9? What and what that will add to 9 if you do some groupings? Do you see something? I need a 8 and 1. See your partnerships? The 8 and the 1 will get you the 9 in the middle. Okay, so x times 2x is the first. and I'm grouping the 1x with a 1, the 2x with a 4, and then plus plus. Okay, what style of factoring should I do the bottom? Negative out. That turns my x to be positive, and the number is now a plus 4. Okay, so it switches everything. And now x plus 4 can cancel. And then I get that on the top and that on the bottom. And if you really want, you could divide that, which would go negative 2x minus 1. If I could divide it all by negative 1. All right, last one. So I have my factoring types. So on the top, I'm going to GCF. Can you GCF something on the top for me? So it looks like I could do a 2m out. So if I divide by 2m, I get m. If I divide by 2m, I get 1. All right, on the bottom, you know what? We're also going to GCF. What does every term have in it that you could take out? An m. Okay, on the bottom, I'm going to keep going. I can keep factoring this bottom. So this portion of it is a simple trinomial. So I'm going to keep the m and then break down the trinomial yet. Multiplies to 2. Don't have many choices. 2 times 1 adds to 3. Okay, what kind of multiplier would cancel? So m plus 1 is a multiplier on the top and bottom. And m is a multiplier on the top and the bottom. So if I cancel that, what's on the top, what's on the bottom? Okay, if you're asking yourself this, why is Mrs. Falk not canceling these 2's? The reason is this is not a multiplier. This is added with that, okay? So that's why I kept asking you what multiplier could I cancel. So this is not going to work, okay? It's just like me doing something like this, right? This is 9 over 5, right? Do you see that the canceling would turn it into 4? That's not what it is. This is not what you're thinking. Okay, so canceling can't happen with adders. Canceling can only happen when it's something times something times something. Multipliers, okay?